Welcome back, everybody. It's been a while. Today we're going to be installing some ventilation in this shipping container. Now, if you guys watched my last video, you'll know why I need to get some ventilation in this container. But if you haven't seen that one, basically what's happening is I'm getting the dreaded condensation problem. Now, this is a problem that a lot of people have with these shipping containers. Something to do with the temperature differential, and when there being a lot of moisture in the air, it just accumulates on the top of the container, and then they basically call it container rain. So everything's getting wet inside the container, and that's kind of the opposite thing that I want to be happening. Like, I bought the shipping container to keep my junk dry. So we're going to be putting some ventilation in there to kind of force the air through it and hopefully dry it out. My 3 goals with this video are: 1, to come up with a good off-grid solution to ventilating these containers. So that means no shore power, no 120, solar power only, and kind of easy to do. My second goal is to do something that, like, even somebody that's a total newbie to solar would be comfortable with. This is like pretty much the most fundamental, easy solar project that you could think of. And there's no batteries involved. It's just direct solar panel to motor. I have a little bit of experience with solar after having done the solar system for my cabin here, but this should be super easy. You know how that goes when I say that. My third goal with this is I wanted to come up with something that was affordable. At the time that I bought the components for this project, I believe I paid under $150 for them. Now it might be a little bit more, might be a little bit less, I'm not sure. But that being said, I will put links in the description of this video to all the parts that I'm using for this project. That way, if you guys want to try to do the same thing, you can see all the parts that I'm using. One thing I'd like to point out is that there are like pre-manufactured solutions to this problem for solar powered ventilation. However, the problem with it is that, at least the one that I've been able to find, it mounts on the top of the container. And that's a problem for this location because we get so much snow up here. So the vent will be blocked, the solar panel will be blocked. I really need to have a solution on the side of the container so that snow will slide off of the panel and there'll be unobstructed flow to get air through the container. So that's why I didn't buy one of those. I forget what they're called, but they're pretty cool units, but it's just not right for my application. So with all that being said, let's jump into it. All right, a very tedious but necessary step. All of that junk right there just came out of this space. This is kind of my like catch-all area that I really need to like do something about, but got it cleaned out, got it swept up, and now I've got a little bit of a table set up here with tools we're gonna use, components. Yeah, I'll do a little strategizing sesh here so that you guys can have an idea of what I'm doing. All right, I know you guys are gonna make fun of me for this, but this is literally quite as simple as how it's gonna be hooked up. This is the panel, this is the motor. We've got a hot wire on one side and a ground on the other side. That's it. There's no battery, there's no charge controller. When the sun is out and hits the panel, this thing spins and pushes air. Okay? Now, there's one thing that we're going to do to make this a little bit more adaptable and functional. And that is, we're going to put a switch in. Now, that switch is going to allow us to, if you could imagine, you know, electricity flowing, let's say it flows this way, okay? And it makes the fan spin this way. Well, putting a two-way switch in will then allow the current to actually switch direction and have the fan spin the other direction. So we'll be able to both push air into the container and pull air out of the container. Through trial and error, we will know which one works more efficiently to exchange the air out of the container. So that's essentially it. We've got the panel here. We've got the fan in here, I believe, and we've got the switch in here. And I'll talk a little bit more about these components in a minute, but for now, that's essentially it. Just imagine this thing being in a container. All right? Engineering at its finest. Quite possibly the most difficult part of this project is going to be actually getting a vent installed in the container somewhere. When I purchased this container and I had this door put in, this roll-up door, I had them put in two vents. So I had them put in this 12 by 12 vent, and then I had them put in another 12 by 12 vent on the other side of the container at the bottom. My thought was that like having one at the top and one at the bottom would maybe create some sort of convection to get the airflow going, but that didn't work. That being said, that is what I'm going to be using for my port for the fan. If you're going to do this project yourself, you're either going to have to, you know, use a torch or a plasma or a grinder, whatever, to cut out a vent, and preferably it's going to be screened. Otherwise, you're going to get wasps and other sort of critters coming in. So that's one part of the install that I'm not going to be doing that you'll have to figure out on your own. And I'm sure there's a ton of good YouTube videos on how to do it. Let's take a look at the parts that we got. All right, and here we've got our, I forget what they call this, two-way switch, two-pole switch. So one of these is going to be in and out on the fan. All right. We've got some wiring for the switch. These are for a different project. There's nothing in there. We've got some grommets to do the cable connection through the side of the container. We've got automotive fuses and fuse holders so that we can make a fused connection. This is solar panel mount bracket. This is for another project. And then we've got the solar panel right here. So that's pretty much it. Oh, and the fan. Where is the fan? This fan right here is a radiator fan for a car, and it just runs on straight 12 volts. But essentially this thing is going to mount up, oops, right like that. And then we'll have a cable running across here, a switch, and then a panel on the outside. Let's take a look at the panel. All right, this is a Renogy 50 watt panel, and it looks like the open circuit voltage is 22.3, optimum operating voltage 18.6. So this is going to be perfect for that little fan right there. Now that you guys have an idea of the parts that we're going to use for it and some semblance of how we're going to hook it up, I'm just going to start chipping away at this thing. So I think that the first thing that I'm going to do is probably mount the radiator fan, is what I'm thinking. Here you go. Now this thing's mounted. I kind of actually lucked out because this little piece of metal here around the screen that they put in and the angle that they used to weld into the side of the container, there's like this kind of little bead of silicone in here that I was just able to go into. I actually didn't even have to drill into the metal at all, but it's still super solid. Now that that's hooked up, let's do the panel. All right, now that we got these mounted up, we can do these, and then we can mock it up against the side of the container, lay the holes out, get it drilled and ready. All right, this thing is ready to go up against the container now. Gonna go up and make a couple level marks up there, and then we'll have something to measure off of. All right, I thought it was quitting time, but it's only 3:30, and that is the magic of living in the woods. Now I've got to go back and find some decent hardware to get it mounted up. I think we'll be able to knock this out before it gets dark though, which is exciting. All right, everyone, it's the next morning. Really nice day up here. Got that thing mounted up last night. And the fan's mounted, so really all we got left to do is wire this thing in. Now, what I was gonna do to get the wires in from the solar panel was drill through the side of the shipping container and then put a little grommet in there. Well, we've got this air vent here that looks like it's just the perfect size to fit a couple wires through. So I think that's what I'm gonna do. And yeah, so we'll have from the fan, we'll have a fuse and then a switch. And yeah, that's pretty much it. I was gonna put the switch down here to make it more accessible, but I'm honestly not going to be switching it on and off very often. So I think I'm just gonna mount it up there next to the fan. And I will show you guys how I plan on doing all that. So should be pretty straightforward. I think there's only like 8 connections that we need to make. So let's get to it. So with the switch here, you see there's these 2 little slots to screw into the side of the container. But instead of doing that, I just got some rare earth magnets with double-sided tape, just to save myself from having to drill more into the container. And this will work for the time being. If it ends up that we need to make a more secure mounting situation, I'll do that later, but yeah, should work. First things first, I'm gonna get those wires into the container. So instead of doing MC4 connectors, since I'm not gonna be unplugging this thing at all, just gonna clip these and do a butt connector on the inside. So for this guy, we'll just go, I guess, right in like that. There it goes, finally. All right. So, cables through the side of the container now. All right, that took a little bit longer than I thought it would. So this is all good now. Now we can start wiring it, finally. So, first things first, we'll put a fuse in on this side. So there's the switch mounted up, and clean that up with some zip ties and maybe some little sticky things to keep the wiring tight. Now all we got to do is wire the panel in, and that's it. Now, I'm not really concerned about polarity here because, well, for one, this is going to switch the polarity and make the fan spin a different direction. But this one's positive here and this one's negative. And what I'll do is I'll just make some jumpers from these, kind of just eyeball it over here. I might even actually run it through this little clip here, or this little tie down. And then, these wires will come back up through here, kind of clean it up a little bit. Cut it here, cut it long. So, in terms of connections, we are done. We've got the panel outside, coming inside. Switch, fuse, fan. That's it. And we have sun on the panel. So all we got to do now is pop the fuse in there and see if it works. 10, 3, 5. There we go. Switch is off. All right, moment of truth. Hope nothing blows up. It's going a little slow, but it's working. I think we got a little bit of shade on the panel is the problem. That tree's blocking it. So while we wait for the panel to get a bit better light so I can show you guys this thing actually working, which it is kind of right now, but not super fast, I am going to clean up all of this junk. Wonderful. Can you guys hear it? It's cranking now. It's actually putting out a really decent amount of air, which is cool. And I can hear it just speeding up more and more as this panel gets more into the sunlight. I think there's maybe one corner of it down there that's still getting a little bit blocked. So in that configuration, we have air pumping in, and then I can switch it down and it will pump air out. How about that? Sounds like a jet engine or something. Now, it occurred to me when I was editing this video that I may have a couple people asking some questions about the voltages here. That panel says it puts out 18 volts, and of course we're using a 12-volt fan. And normally that's bad. Like if you put 18 volts through anything 12 volts, like you're gonna burn it up eventually. Now, I didn't check this, but from everything that I've read online, like that panel is rarely going to be putting out 18 volts. And on top of that, you've got the motor that's acting as a big resistor, which is going to drop the voltage even more. So I got my voltmeter here. We'll test how much voltage that panel's putting out. And then if it's like anything over, say, maybe 15 volts, because that's kind of on the top end of what a car might put out. It's really like 14 volts from the alternator. Then I might consider putting a voltage regulator on there, which is really simple. It's just like, it's basically like wiring in almost another switch. There's 2 wires in, 2 wires out. So I've got my voltmeter here. This thing, by the way, has been going for several weeks now since I installed it, and doesn't apparently have any issues. Still cranking out a lot of air. It's working exactly as it's intended. So again, this is not an easy place to record. Can you guys see that? So that thing is in full sunlight right now, and it's only putting out 10 volts. So to me, that's like well within the tolerance of what this thing can handle, because this thing should be able to handle, I mean, it's got a sticker for 12 volts, 80 watts, which is, what is that, 6.5 amps? But yeah, I mean, in the summer, the voltage might go up a little bit more because the sun intensity is greater, but I think the panel is angled in such a way that I'm really not going to get anything better than I am right now, because I have it angled for the spring sun. So as the sun in the summer gets higher, that angle on the panel is going to actually be worse. So I'll probably get less than 10 volts in the summer if I had to guess. 10 volts. So anybody that was wondering about the 18 volts versus 12 volts, I hope that makes sense. I mean, does it make sense? All right, everyone, that's the sweet sound of success. I know that there's going to be some people out there that are going to say, hey, what's up with that? What's up with that? I'm going to fix it, but I'm not going to do it in this video because I don't think you guys need to see me tidy up wires. Basically, I'm going to get some like little stick-on zip tie clip deals and just clean it up a little bit. But for the purpose of this video, I'm going to go ahead and call it and say that it's a big success. I really hope that this helps even just one or two people out. If you have any questions or concerns or anything really, leave it in the comments and I'll try to answer you. But other than that, I'm going to say thanks for watching, guys.